So hello and welcome to my presentation titled Alternative Futures, Terraform and Kubernetes. This presentation will be about where we are today with Kubernetes management and Terraform, and I will present some alternative possible futures when it comes to how you would manage your Kubernetes resources with Terraform. So my name is Phillip Laine. I work as a DevOps engineer at Senate. Mostly my day job is managing Kubernetes clusters for customers. I work with tools such as Terraform, Kubernetes, Azure, AWS, and I do a lot of Go programming. I'm also a Microsoft Azure MVP and a Flux maintainer. If you want to get in touch with me, my contact details are below. Great, so for today's agenda, we'll quickly cover the basics of Kubernetes, or what you need to know for this presentation. We'll do the same for Flux, talk a bit about Terraform and Kubernetes, the current state of affairs, and I'll also then walk through some alternative solutions. So if you aren't aware about Kubernetes and what it does, all you need to know for this presentation is that Kubernetes is a platform that runs containers. It is configured through declarative resources, and this is kind of the more important detail that you need to understand. The way that you interact with Kubernetes is through its API server. These declarative resources are defined in a format called Kubernetes Resource Model, or KRM for short. The image to the right is an example of a resource that follows the KRM model. So you would have a API version always, a kind, which is the type of resource, metadata with name and labels, and then a specification or spec. The spec is what is different between the different kinds that are available, and they are different also depending on the API version of the kind. So as breaking changes are made to a specific kind, a new API version will be released for that kind. It also means that as Kubernetes versions are released, API versions may be deprecated and removed. Within Kubernetes, there are core API resources that are part of the Kubernetes project, but then there's also an option to define custom resource definitions. These are open API specs that define out-of-tree Kubernetes resources that other projects can define that also follow the KRM model. So Flux. Flux is a continuous delivery tool built specifically for Kubernetes. It is very typical or very similar to most other continuous delivery tools, with the exception that it follows or implements a concept called GitOps. So if you think about traditional continuous delivery solutions, you have the pipeline that pushes in configuration into the cluster. With Flux instead, you would run Flux inside of your Kubernetes cluster. It would reconcile from a source of truth. Initially, this was only Git repositories that were supported, but as time has gone on, this source of truth could be, for example, an S3 bucket, or maybe in the future an OCI registry. So the Flux daemon inside of your cluster is reconciling with the source of truth. It will then apply the Kubernetes resources to the cluster. And any changes as they're pushed by the developer to the source of truth, they are then synchronized and pulled in and applied again. The Flux Terraform provider is a provider that the Flux project has built to support installation of Flux in a Kubernetes cluster. The process of installing Flux into a cluster is called bootstrapping. So what happens is that you have to add the Flux resources to the cluster, but then point it to a source of truth. For example, a Git repository, where its own definition is. So this bootstrap process allows you then to update the Flux installation through Flux itself. It was initially developed to fit a specific need that end users have, because they wanted to work with Terraform and Flux. So they wanted to create their Kubernetes clusters with Terraform and then bootstrap their cluster, or the cluster after it's created, with Flux, so that developers could then deploy applications. It has right about now 2 million downloads, and initial development started about 2 years ago. At that time, I wasn't too familiar with provider development and also how interactions or other Terraform providers interacted with Kubernetes. It has taught me a lot when it comes to provider development, and we're currently in a redesigning phase of the Terraform provider to look at easier methods or simplifying the interaction with a Terraform provider to make it easier for newcomers and beginners who are wanting to install Flux with Terraform, but don't want to do the amount of work that is required today with the current provider. So Terraform and Kubernetes. Kubernetes applications tend to not live in a vacuum. They tend to interact with other cloud services. So unless you're running, for example, all stateful applications inside of your cluster, they tend to want to talk to other databases or other types of cloud services like Service Bus or some other messaging solution. Kubernetes itself is also a very bare bones project, if you want to call it that, which means that to extend functionality that help developers deliver their applications, it requires additional applications that don't come from come in a vanilla Kubernetes cluster. So this requires you to add platform applications like Ingress Controller or external DNS or a governance solution or all of the above to a Kubernetes cluster after it's been created, but before the actual business logic applications can be deployed into the cluster. There are strong synergies here between creating cloud services for these platform applications running inside, getting outputs from output parameters after the resource is created, and then putting them into the resource definition that is applied to the cluster. So there's a clear life cycle there where there are a lot of people who enjoy, or they are pushed to use Terraform to manage Kubernetes resources just because they have this typical life cycle of creating a cloud service, getting an output parameter, putting it into a Kubernetes resource, and then applying that resource to the cluster. But at the same time, this is a typical solution that cluster operators would use, but we still see that the majority of the people who develop applications internally tend to use other continuous delivery solutions like Flux, just because of the application lifecycle or the development lifecycle is very different compared to the platform applications that you might deploy into your cluster. So there are a bunch of different options out there today when it comes to managing Kubernetes resources with Terraform. There are a couple of providers that I use on a daily basis. There are probably a lot more out there than I know of myself. I will talk about the most popular ones that I feel are relevant. And then you also have the HashiCorp null provider or the null resource, which is technically a solution that you could use, but is nothing that I would recommend people to do, to basically shell out and have Terraform run a shell script for you. So we will not be focusing on that, but even though it's an option. The issue with the other providers that I am going to discuss is that they all have at least one downside. So this is, the downside could either be that they can't manage custom resource definitions, or they have issues when it comes to resource dependencies. So when I say resource dependencies, I mean that you might want to create one Kubernetes resource or deploy one application before the other. So a typical use case might be that you were deploying a governance tool like OpenGatekeeper or Kyverno into your cluster, which enforces some sorts of rules to other resources that you're creating. In those scenarios, you don't want, or you want to make sure that your governance tool is running and is healthy before anything else is applied. And then the third downside that might occur is API versions to your resource model might cause breaking changes where Terraform will force recreate the resource. So the Kubernetes provider built by HashiCorp is probably the most common provider that people use to interact with Kubernetes. It is also the simplest and the one that is used in a lot of examples. Initially, during its first versions, it only supported the core Kubernetes APIs. So you couldn't manage custom resources with this Terraform provider. And there are a lot of technical reasons why this is the case. It uses HCL instead of YAML. YAML is the common way to define Kubernetes resources, but in this case, it uses HCL. The big issue currently, as I see it, with the Kubernetes Terraform provider is that managing or updating API versions is still not something that is easily supported. So it is possible to do state migrations where you would move a resource from one API version to another without breaking the resource. So forcing to remove the resource and then add it again. But it still requires a certain amount of user involvement and understanding of the KRM model to do this in a safe and secure way. And it does now support arbitrary resources, custom resources, but it uses something called server-side apply in Kubernetes. I won't go into the details too much, but what this requires is that the Kubernetes cluster has to be created at initial or before the plan is run that is going to use server-side apply, which means that you can't create the cluster in the same state as you're applying the resources. This is a pretty contentious opinion regarding if you should have separate states when it comes to creating Kubernetes clusters and applying resources into your cluster, or if you should use, or if it's okay to do this in the same state. My personal opinion is that there should always be the option to do this in the same state. So that's probably also another issue with the current Kubernetes Terraform provider, where it requires you to have separate states. So two separate applies, one to create the cluster, and then another one to configure resources in the cluster if you're using the server-side apply functionality with this provider. This is how a resource defined with the Kubernetes provider would look. So in this case, we're creating a pod. There's a pod of V1 in this case. It has metadata, it has a spec. It's very similar to the initial example that we saw before in YAML, but in this case, it's in HCL. So another option out there is the Terraform Helm provider. Helm is a tool used to manage and package manifests, but also template the YAML files from a configuration file, basically. So it is an extra abstraction on top of pure YAML definitions. It's probably the simplest way if you want to do apply multiple different types of resources with Terraform without having to define everything yourself. It's easy to template, so you can pass Terraform variables or outputs as inputs to the Helm templating engine. It supports managing Kubernetes resources of any kind, so any custom resource would work with the Helm provider. The issue, and this is not a limitation of the Terraform provider itself, but a limitation of Helm, where Helm will only install custom resource definitions the first time, but if you upgrade the version of a Helm chart containing a custom resource definition, it will not upgrade these custom resource definitions. this adds a lot of limitation when it comes to managing or versioning some Terraform module, for example, where you wouldn't know if the latest CRD is actually applied or not. And it seems like the recommended way today is to manually apply the updates before you run Terraform. Another issue, which is also not the provider's fault, is that there are a lot of edge cases when it comes to state diffing and health checking. So making sure that a container is actually starting, making sure that the manifests that are generated by Helm are actually present in the cluster. From my own personal experience, I've seen a lot of issues when it comes to figuring out these types of weird edge cases, and they're more common than you'd expect. But this is how you would configure a Helm release in this case. So you have the name of the release, the chart name, and you have a remote source and a version of the chart, and you'd pass in some values for configuration. Yeah, and then you have the kubectl provider. So kubectl is the name of the CLI that you use to interact with the Kubernetes API. There is a Terraform provider that attempts to mimic the kubectl behavior. It's probably one of the best non-HashiCorp Kubernetes providers out there. It's good when you want to manage CRDs because it takes pure YAML as input. So it is very similar to interacting with Kubernetes in a more traditional vanilla way. One issue with this provider is that it does not support passing multi-doc or multi-part YAML in the same resource. So multi-doc YAML is when you have one YAML definition, then you have 3 dashes, and then you could define another YAML document in the same file. So this is not supported in this Terraform provider. Another issue with it is it does not support, it doesn't even support API version updates in a non-destructive way. So it has the same issue that, or a similar issue that the Kubernetes Terraform provider has, where if you update the API version of your manifest, it will then see this new, even if it's the same resource, it will see the manifest as a new resource, and it will remove the resource and then recreate it. This is obviously something that you don't want to do, because instead you'd want the Terraform provider to apply the new version of the same kind immediately. And it also has a lot of issues when it comes to multi-part YAML and dependency complexity there. So what happens is that you'd have to split a multi-doc YAML file into multiple parts and then iterate through the resource if you want to apply it. And this creates large amounts of complexity. So this is how you would define a kubectl manifest if you want to do it in that way. So hopefully it's not time to just give up. All providers have their issues. And hopefully this is the part where I offer my own type of solution for these types of problems. But I think it's first important to find our own set of criteria when it comes to what a good solution would look like. So obviously we want to have the option of templating cloud service outputs into a Kubernetes resource. We want seamless API version upgrades. We want to be able to install and upgrade CRDs. We want to have custom Kubernetes resources. And we want to have a good solution to define dependencies between applications. So this is the point where you start to realize that maybe Terraform is not the best solution to manage complex Kubernetes resource or application deployments like platform applications, where you might have 10, 20 different applications that are running, that are doing their own small part just to be able to set up a functioning Kubernetes cluster. Flux, on the other hand, is a purpose-built tool that manages Kubernetes resources, and in its way, it fulfills all the criteria that we've already described. And in my case, for example, if you're already using Flux to manage internally developed applications and their lifecycle and how they're deployed, the question is then, well, why are we not using that to manage our platform applications? So it might be the compromise between only using Terraform to manage Kubernetes resources and only using Flux to manage Kubernetes resources. So the proposed solution or alternative solution is basically to ignore or to avoid using Terraform to directly interact with Kubernetes. So in this example here, in this alternative solution, you'd still use Terraform to create your cloud resources, but then you would template your Kubernetes resources, generate them, and then push them to the source of truth. And Flux would reconcile the source of truth. So you'd obviously first have to create the Kubernetes cluster with Terraform, then you'd have to bootstrap Flux into the Kubernetes cluster with Terraform. But when those two things are done, and currently then the only interaction with the Kubernetes API from Terraform side would be the bootstrapping process of Flux. But all other configuration changes are done from Terraform when it's interacting with the source. The reason, and one question that could be asked is, well, why have Terraform do this work against the source of truth instead of having, for example, a operations person do it manually? Well, the answer is really that Terraform is used more of as a Flux update automation tool. And the reason why you would want to do this is mostly because there are probably a lot of dependencies between, for example, the Kubernetes configuration, the version of Kubernetes that you're running, and the specific platform application that you're running. So you actually want to keep the versioning of the platform application manifests and the Kubernetes cluster creation tightly coupled with each other. You don't want to drift between these types of changes, basically. So what Terraform is doing is it's doing the same work that you might do if you were to use Flux today to manage your platform applications, basically. And this might actually be a better option if you want to do this manually if you have 3 or 4 clusters. But if you have 10, 20, 40, 50 clusters, or even more, going in and managing the manifests that are being deployed into the cluster with Flux manually isn't really an option anymore. So what you're doing is you're relying on Terraform to do manifest management instead of doing it yourself, basically. One issue with this is that it requires Terraform to make Git commits for you with a Terraform provider. Flux is adding support for OCI registries in the coming future, hopefully. And this will probably simplify things a lot. So instead of having to push manifests to a Git repository, you can push the manifests to a Docker registry and have it pull from there. And there are a lot of benefits with doing it this way. Another downside would be that you would introduce more points of failure with the complexity. So instead of having Terraform directly interact with your Kubernetes cluster, you're now relying on a separate tool and a separate reconcile loop, and there is interactions from Flux to your Git repository that could fail. So there are a lot more failure points in this solution. But at the same time, it removes all the dependency planning that Terraform has to do today with a bunch of Kubernetes resources. And if you end up managing a lot of Kubernetes resources with Terraform, you start to realize that Terraform Kubernetes clusters and Terraform state isn't really the best combination. And there are a lot of issues that you can find yourself in when it comes to like figuring out how to deal with apply order and things like that. And the last part is that the reason I think that this solution is going to be a lot better for the future is that you play into the strengths of Flux when it comes to, for example, dependency management and health checking. So it's then easy to do, for example, to make sure that your governance or policy engine that's running inside the cluster has to start, be healthy before other applications are being deployed into your cluster. And these are the types of things that are really, really difficult to do with Terraform today, just because of dependency ordering can break very easily when you work with Kubernetes manifests. So this would be an example of how you would do it. In this case, I'm using the GitHub Terraform provider as an example. So instead of just applying things, you'd have to bootstrap the cluster, and then you would commit your manifest straight into your GitHub repo. And what this example doesn't have, which you could have as an example, is templating in other parameters from creating some other cloud resource before you would commit this into Git. You could do multi-doc YAML in this case, so you could have one file with large amounts of Kubernetes manifests. So that's also an option. But if you've ever worked with Git or committing things with Terraform, you realize that there are issues because you end up with Git being a state and Terraform having its own state. And there are a bunch of different state updates that occur where you're not really changing anything in your Git repository, but Terraform has to update the Git history to be able to track the state. So you end up with a lot of dirty plans, basically. So this isn't really the option that I would go for. Instead, I think that as Flux adds OCI support, the options to skip Git altogether and just use registries is going to be one of the best options out there. So what's going to most likely happen is that Flux is going to implement a Flux push command, which allows you to, or what the Flux CLI is going to do is that it's going to package together manifests in the directory that you give, make it into an OCI binary, push it to a registry like ACR or ECR in a prepackaged way, which Flux can consume. What we could do is that we could expose the same type of functionality through the Flux Terraform provider. So instead of interacting with Git, we could have Terraform track changes to directories. And if, for example, the hello world directory changes in any sort of way, we could then push these or build a new OCI binary and push them to the registry. And I really think that this is kind of the future or the alternative future if you're kind of you don't want to go the way of dealing with Terraform manage Kubernetes resources. So as a conclusion, I just want to say that there are still a lot of challenges with Terraform and interacting with Kubernetes. Hopefully, I haven't been too negative about the other different providers that are out there. I think that they're great. I just think that they are not well suited for long-running clusters with large, complex manifest definitions. And I think that this as a alternative future, I don't think that it's going to be a common solution, but I think that it's important to discuss the different types of options that you have out there that avoid the different types of Terraform providers and all the small downsides that each provider has, where you're forced into using multiple providers to deploy the same application. Another challenge that we have today is that we still need to bootstrap Flux with Terraform. So Terraform still needs to have access to the API server to do the initial bootstrapping. So that's kind of an interesting subject area where if you could avoid that totally, you would kind of solve a lot of issues in just one swoop. And I still see that there are going to be people who look at the complexities of using Terraform to manage Kubernetes resources and will see this and go, I will only use Flux to manage my Kubernetes resources. And that's fine. And I see that a lot today, but it's mostly people who have few enough clusters where this is feasible. So the solution, that the alternative future solution that I'm proposing is basically looking at an option where where Terraform is an automated operator where you can manage versioning of your cloud resources and your Kubernetes manifest in the same location, basically. So hopefully you've learned something today. That was all. Thank you.